Sorry that video ended, so we'll pick up right where I left off. And I know that the square root of 15 falls between the square root of 9 and the square root of 16. And 9 and 16 are perfect squares, meaning that I get whole number answers. So the square root of 9 is 3, and the square root of 16 equals 4. So that means that the square root of 15 has to be between 3 and 4. That does not mean that it's 3.5. It does not mean it's 3.5. It is not always 3.5. As you can see, 15 is much closer to 16 than it is to 9, so my answer needs to be closer to 4 than it is to 3. So I need an answer of 3.8 or 3.9. This little symbol right here does not mean equals. It means about equals. It's not just crooked. And I would say that this answer is about 3.9. Now, notice that I ended that one digit after the decimal point, and that's because the tenths place has 1 0, so I go one digit past the decimal point to find the tenths place. That way I can estimate that. Let's jump over to this one. I know that this is between the square root of 36 and the square root of 49. 36 and 49 are perfect squares again. And the square root of 36 is 6. The square root of 49 is 7. So I know that my answer is going to be between 7 and 8. Or sorry, that's not correct. Between 6 and 7. And 38 is closer to 36 by quite a bit. And so I know my answer needs to be closer to 6 than it is to 7. So I'm going to estimate my answer at around 6.1. Since it's an estimate, it doesn't have to be exact. You don't have to pull a calculator out and get an exact answer. You want it to be close. 6.2 would have also been counted because it would have been close. Last one of these I'm going to do, and then I'm going to show some of the fraction division down here. The square root of 60 is going to fall between the square root of 49, which equals 7, and the square root of 64, which equals 8. And I can see that the square root of 60 is closer to 64 than it is to 49. And since 60 is closer to 64, I want my answer to be closer to 8 because the answer to this is 8. And the answer to this is 7. Now, notice it's not just 1 or 2 away. It's 4 away this time. So I don't want to say that the answer is 7.9. It's probably 7.7 or 7.8. Those would both be good estimates. So I would say that it is about 7.8. And that would be an accurate guess. Give me just a second. I'm going to see if I can scroll down the screen. I don't know if I can. So I'm going to have to pause the video. And I'm trying to jump back to this. There we go. So the first division question on your DMR here is 1 5/7 divided by 3/4. So once again, I did the denominator times the whole number. 7 times 1 is 7, plus 5 gave me 12/7 divided by 3/4. Last year we did this quite a bit where we did keep, change, flip. So I need to keep 12/7 the same. I need to change the division symbol to multiplication, and then I need to flip 3/4 to 4/3. When you divide fractions, we do keep, change, flip. So once again, I kept this the same, keep. I changed this from division to multiplication, and I flipped 3/4 to 4/3. And then I just go ahead and multiply. 12 times 4 is 48. And 7 times 3 is 21, so I get 48 over 21. And then I count by 21s once I get my denominator of 21. And 21 and 21 is 42. And I realize that 21 fits into 48 twice. So I get a whole number of 2. 2 times 21 is 42. 48 minus 42 leaves me with a remainder of 6 over 21. And just like the last answer of 6/21, 3 goes into both of those. So I need to divide this by 3 and the 21 by 3. And when I do that, I get an answer of 2 and 2/7. So on your DMR quiz tomorrow, you're going to have multiplication of fractions and division of fractions. With multiplication of fractions like this, you just multiply straight across the top. When you have division of fractions, you use keep, change, and then flip 3/4 to 4/3, and it'll work the same on all of your division problems. Your only assignment for today is to study for the DMR quiz. You even have the DMR quiz attached to your DMR, so you can go ahead and take the quiz today, practice it. It's probably going to be